Okay, welcome back. This is the second video in a series of two for 3D scanning using the NextEngine scanning solution. So, welcome to the interface that you get with this solution. So it's Scan Studio HD. And while the colors are a little bit like a kid's program, it's a really powerful tool. I love it. The only thing I love more than that is the greatest scanning application in the history of time, and I kid you not. It's the SolidWorks of reverse engineering, which is RapidWorks. Just an amazing application which can allow me to do things that blows me away even after having learned how to use it well. So we'll just start right from the beginning. So just to hear, this is what that tool looked like when I received it. So it's obviously been turned. They weren't too interested in what was on the inside because that's just there to as a spacer. And the material, the platinum that's actually pressed onto this only comes up to there. So this part, this is why this is relatively rough, and this is baby smooth. I then scan this with various aids to allow me to deal with the issues that go with scanning in general. And that looks like that. Yes, this is at the very screen that I'm viewing this on now. So as you can see, this has been covered with basically talc spray, and I've used little red dots to help me get reference. And there's a reason for that, because this is a perfectly cylindrical object, and as you can tell, perfectly cylindrical objects, it's very difficult to tell which side you're on. So the application ends up going, well, I don't know which one is which. So I give it references with small dots, which didn't work out as well as I wanted to. In fact, I use other methods now. I no longer use that process. It works well with some, but not all. This is a little lump of modeling clay. As you can tell, it's just a chunk. I put marks into the side, and it's used to allow me to use an organic form to reference the images. I'll show you what that means later. So that's all the scans I took. I took it on the side. I needed the inside curve here, so I did various ones of that nature. And yes, the pole gets removed later on. Now I want you to take note here. See, there's a reflective line down the middle, which is basically because, you know, uh, light is being hit onto something very reflective, and even with the talc, it still reflects through because that damn thing is really shiny. See that line there? That's what I'm talking about. I'll talk to you about why that's important in a moment. I just wanted you to make reference of it. So that's what the final result was like. I'm pretty proud of that. That's a pretty good scan. There are some small imperfections, but as you can see here and here. But most people would say that's not bad at all. This is the final component, which was really just to take the profile of it. So I used the tools in this to be able to allow me to create that what's called a polyline. Excellent little application. And this is the polyline created into Rhino 3D. It's just a curve, so that's all they needed, and that allows them to put it into a CNC lathe and turn the thing to their best desires. Now, let's come back to the beginning. You can use this solution, is in Scan Studio 3D, excuse me, to do a lot of work here. You can, I could go through all this, but since I own and operate RapidWorks, which is the far more advanced solution for this, I just go straight to this. As you can see, what is here are each individual scan and component, so I can obviously and I can turn these off as I wish. Just hit the little eye so they become invisible and address each one. So the reason I'm doing this is because I'm going to show you what each scan is like, which you would normally get through the native software that comes with the application. Now if we come up very close to this, you can see the nature of, yeah, hang on a sec, there we go. So that's some pretty decent scanning. As you can see here about what I said in the previous video about having a line from this point to that point and then a million scans in between, and It's not really necessary. It goes from there to there, and you can just extrapolate between. Where you need the detail is on these curves. I'll just pull this over, like on the crown here. So this is still a fairly geometric shape, but this is where greater resolution is required. Now, the resolution I used for this was completely appropriate, and the client was very, very happy with the result. But as you can see there, it begins to stretch itself, only because of the position it was in. This is why I took the unit on its side. But this is the kind of evaluation you make. Some people criticize the NextEngine scanner as, well, that's a little bit of a home hobby kind of solution. It's not really the big boys' toys. It's not the big boys' toys, but it's not a home hobby solution. It has incredibly strong capability and is used for all sorts of places. I can show you images of what is done for aerospace with it, etc. Images like this. As you can see, that is literally the unit that I use, and this is for scanning that forward surface. There it is inside the acoustic evaluation center. Right down, looking at the blades, and that is for a much smaller unit. But as you can see, this is completely applicable to all sorts of industries, and don't underestimate the power of this little unit. Just because it's not handheld does not mean it isn't a force of its own. What I can tell you is that I have had scans done by the big boys, paying $3,000 for the scanning of an aircraft, and it had all sorts of errors all through it, which was just handed to me as a raw file and said, okay, thank you very much. I don't do that. When I produce a result for someone, it is the final solution, perfectly smooth for any erroneous data removed. It's professional work, rather than just $200 an hour for using my very expensive piece of equipment. That's not the business I'm in. So, now that you've seen the general, and also let me just, there's various other kinds of displays I can see, and even the original photogrammetry stuff is on there, so you can tell what it looked like. Let me put it up here. Yeah, and with that you can see how accurately it can actually capture things. There's the imprint of the serial number for it, or for this tooling number. Alright, now to the job at hand. Now let's turn, well, first before we go, notice it has a hole here. Now why would that be there? Considering everything else is so beautifully done. This is because this line, coming back to, is that point of reflection. At that point, the lasers have a great deal of trouble figuring out what on earth is happening in this situation, so they basically admit it. That's not exactly what's happening, but it's close enough to that. So that's erroneous data right here. Let me come down a little closer, and let me give you another display. That data here is less than happy. If you say smooth from here to there, it'll get this very, very nice, and obviously we're at a very fine detail there, so hence why the waviness. That's probably about less than 100 microns, to be honest, the variation here. That component will be smoothed in with these elements. So it's getting something that is a 1, 1, 1, 5, 1, 1, 1 numerically. So it's deviating all of this just to cater for that. So instead of doing that, I would rather just remove that complete component, get another scan from another angle that has this kind of surface, and lay that across that, and then merge the two together. So let me just show you what that looks like. And here we are. So this is the next file along, which is everything trimmed and merged. Now you can see there the sections that I cut out. This was data that I identified, just something went wrong. And I found that this is where I mentioned about the Posca pen little red dots. Some of those dots, because it's red laser light, showed up as lumps because they were higher points of return of light, because they were red and the laser light's red, so therefore it saw that as, you know, more of itself coming back. Sometimes that doesn't happen, sometimes it does, and in this situation it did. So I removed some of those, but because all of these images overlap, let me just show what a little bit more in detail of what that's about. Okay, so with this image, here's a really clear example of where the data was great and I cut out little bits that weren't. Now, to be honest, the client didn't want this tooling mark here. They punched that for a certain reason. Because in the selection device they have, they grip it with this thing. I wanted that in there just to demonstrate how accurately I could take something that was in a regular odd shape and reproduce it, just to show them that the capability of the solution. They like that. Now, there's a hole there. So what do? I then cover it with another hole, with another hole, with another surface. So this one had huge holes through it. But it's not a problem, because if we use these two together, it works. And also here is an example of what it looks like for multiple scans to create a singular surface. So we have the green there and the yellow there, and together they fill each other in, and seamlessly. This application, because of its statistical analysis component, can analyze the nature of where they should go perfectly. As you can see, this is not self-aligned by myself. The application did this through understanding how curves are created and what is the likely statistical probability of one forming another. You do have the ability to play with it, just in case it gets it wrong, but it doesn't get it wrong that often, I can tell you. It's outstanding. Anyway, that's the basic process. This is how we do it for something small. This is how we do it for something really large. And it can create an outstandingly good quality of surface. You can even see here, do you see that line there? That is incredibly difficult to see on the actual physical item. Actually, no, there it is. It'll pick that up. What it won't pick up is the RMS, the exact surface. See these tool lines? It won't bring that up. Oops, there we go. Only because you really need to. I didn't scan this to that level. I can bring it up, but that makes the scan go on for forever. With that number of scans and that accuracy, it would be 3 to 4 hours just to scan the damn thing, let alone all the post-processing. Oh, and one other thing. So here's my file. There's 4 gig of data for this particular piece inside of that one, and they're all the files that went through the various iterations and alterations that I had to do to make this work well. There's a fair bit of work involved. Having said that, this part was $300. Why? Because I like to be value for money. And as a result, they said, great, we have a whole series of these to do. That's an outstanding price, great result. We keep all the data, and I provide them with everything they need. So that's it. One final solution, $300 for this one part. Now, moving right along. That is all the scans together, folded over each other, trimmed and aligned. I could show you the aligning process, but it does take a while, and it's kind of leads you to where I am now. Instead, I'd like to show you how to finalize this thing. So I'm now I'm going to bring up one of the other files, like this. So this is what it's like to have all of the scans fused together into one continuous mesh. It still has some issues. As you can see, there's a crack there. In the actual, not in the actual part, but in the mesh. So what we do now is we go through and do a whole lot of, so you can fill holes, you can smooth it, you have sandpaper. That's right, a little hand, and you go through and you can sand something that's sticking out or not quite right, and it recreates the mesh. You're defeaturing and removing selected poly surfaces. You can thicken it, you can adjust the boundaries, as I've actually done here. You see the bottom has been trimmed so that it's nice. Well, where are we going? So it's relatively straight. Actually, no, I haven't done that, to be honest. Not at this point. That's in a later component. And a whole lot of other healing components. This is absolutely magic. This was what was not done for me for my scan done out of the United States. And if it was, the data would have been 100 times more usable. It was so much more difficult to use. So I'm just going to now move on to the next component, which is what it's like after it's all been healed over. So this is the final component. You can see how the bordering had been done here, and you're looking inside it from underneath. That is the interior of that hole that was punched with that tool. Now that's actually what it looks like on the inside. So that's the ability this has to recreate three-dimensional components. You're actually now looking at what it looks like from the inside, which is the surface created by the punch. Now that wasn't needed for this scan, but it indicates to you that there are some things that CAD can't do that 3D scanning will be able to give you, and it's just a great insight into the geometry of what you're dealing with. Next, I'm going to move on to the actual polyline, which is the point of this whole thing to get the profile. Ladies and gentlemen, the final result. So when I said it can look just like the real thing after a scan has been done well, I really meant it. So let's have a look at this. This is all the various planar views. The polyline is there, and that's the part that we're really interested in. If you have a look at, and you can see what that actually looked like. So obviously a drill had gone in or a punch had done this, including the top section, which that had been drilled out. Not bad, I think, if I do say so myself. Oops, up that way and that way. That's all, guys. Thank you very much for listening to my relatively long video. It had some detail to it. I'm going to now finish off with another little project that shows you the capability of what happens when it gets put into context of a physical item, returning it back into a physical item through CNCing. I had a job that I was requested by Williams Patents that said, look, Gus, can you do this for me? And I said, absolutely, guys. And they didn't think it was possible at the time. And when they contacted me, it was a, look, we probably think you can't, but can you give it a go? And I said, no, it'll happen. And that's what's next. This was a bird that was given to me to create into a 1-foot model, but so it can be created into a sculpture by an artist. And it was cheap plastic, and I'll show you what it looked like now. So that's how it began. That's my model, and that is what it looked like after it was CNC'd with foam, I believe, by the gentleman in the background there from Williams Patents. That's the spline model that I had in the CAD, and looked pretty damn good, I think. You can just blow on the back.